This is question number 5 in chapter 7, and it's also course to steer. It's also a type C problem, but with the addition of wind leeway. So in order to do this, we're going to do our standard type C vector triangle solution, and then after we finish that, we're going to add the wind component, the wind leeway. So let's read the problem and see what it says. Here is number 5. You are at point F and want to steer straight to point E. Current is setting at 142 at 2.6 knots. Boat speed is 7.3. Wind is blowing from the north, causing a 3-degree leeway. What course should you steer PSC to travel directly to point E? Well, let's first draw a course line from F to E, and there's that course line. And what I'm going to do is take that line and walk it up to the compass rose and draw it in. Now remember that this line represents course over ground that I want to achieve. Okay, so COG, I read it here and it comes out to be 253, true, in my little table here. Remember that 7.3 was the boat speed given through the water. The current set and drift set is 142. So here is 140, 142 is right there. And I'll draw that line in, and that is the set at 142. Remember, this was COG at 253. Okay. My next step is to take my drift speed, my current speed, 2.6 knots, and I'll set my dividers for 2.6 nautical miles. 1, 2, buckle my shoe. Alright, 2.6. 1, 2, 2.6. 2.6 miles here. I'm going to put that on the current vector, and that represents current speed. Remember, this side of the triangle represents the current direction and speed. This side of the triangle represents course over ground. The next thing that I know is my boat speed is 7.3. So I'm going to set my dividers at 7.3 and plot in that third side of the triangle, just as I've done before. So there's 6, 7, 7.3. So here is 5, 6, 7.123, 7.3. I want to go take this and go from this point on the current vector and swing an arc out here, and the length of that distance represents 7.3 knots of boat speed. I'll have to extend this line out a little that I drew. I didn't draw it far enough. So it's right there. And I can draw from this current drift vector to that point and draw that line, and that's the third side. And this side, you remember, represents a speed of 7.3. To get the course to steer, I'm going to take that line, move it to the center of the compass rose, and figure out what it is. So my course to steer, 273 for current. hard to read that. Now, you remember I have a wind blowing though, and I have to compensate for that. Now, we're going to be steering in this direction, roughly in a westerly direction. The wind is blowing from the north, so the wind will blow us below our course line. Therefore, what we have to do is steer towards the wind. Now, the problem question said the wind blowing from the north is causing a 3-degree leeway. That means that our angle, our course angle, will change by 3 degrees based on the wind effects. So to compensate, I wanted to steer 3 degrees closer to the wind, or 3 degrees towards the wind. And an example of that would be, I'm going to draw a little diagram here. If this is 273 for current, then I want to steer closer to the wind, towards the wind, and this angle between these two should be 3 degrees. So therefore, I want to steer 273 plus 3, or 276. I want to steer 276 true. Now, taking my TVMDC and enter the 276, go through the variation and get of 9 west, get magnetic 285 by adding the 9 west, going left to right in the table. Let's look up the deviation. Well, here's 271 and 300, and 285 is a little bit closer to 271 than it is to 300, so I will choose 1 east as the deviation. And remember, going from left to right in this table with easterly deviation, we're going to subtract. So 285 minus 1 is 284. So the answer to that is course to steer is 284 per ship's compass, to compensate for both the current effects and for the wind leeway effects. That's a type C problem with wind added in.